Welcome to Oryx Learning. Today's lesson is on Unit 6, Triangles and Pythagorean Theorem, Lesson 5, Pythagorean Theorem. Over 2,000 years ago, a mathematician named Pythagoras discovered a relationship between the sides of every right triangle. He found that the sum of the areas of the squares formed with the two shortest sides of the triangle equals the area of the square formed on the hypotenuse, the longest side. This became known as the Pythagorean Theorem, a squared plus b squared equals c squared. The hypotenuse is the side opposite of the right angle. It is the longest side of the triangle. The legs are the two sides that form the right angle. Another way to remember the Pythagorean theorem is leg squared plus leg squared equals hypotenuse squared. Evaluate the given radical and round to the nearest tenth if necessary. The square root of 30. The square root of 30 must be a number between 5 and 6 because the square root of 25 is 5 and the square root of 36 is 6. Using a calculator, the estimated value of the square root of 30 is 5.477, which rounds to 5.5. So the square root of 30 is approximately 5.5. Find the length of the missing side. Round the answer to the nearest tenth. As we can see in the diagram, the hypotenuse is 15 and the leg is 9. We substitute those values in for c and a in the Pythagorean theorem and solve for b. So using the Pythagorean theorem, a squared plus b squared equals c squared, and substituting in the values that we know, we get 9 squared plus b squared equals 15 squared. 9 squared is 81, and 15 squared is 225, so this gives us 81 plus b squared equals 225. Subtract 81 from both sides of the equation, and simplify to get b squared equals 144. Take the square root of both sides of the equation, and we get b equals 12. Is this a right triangle? If this is a right triangle, then the Pythagorean theorem must work. Substitute the values into the equation. 26 is the hypotenuse, as it's across from the right angle, so it's substituted in for c. 10 and 24 can be substituted in for either a or b. A squared plus b squared equals c squared. Substituting the values we have, we get 10 squared plus 24 squared equals 26 squared. 10 squared is 100, 24 squared is 576, and 26 squared is 676. So 100 plus 576 equals 676. Simplifying, we get 676 equals 676. Since the equation creates a true statement, this triangle is indeed a right triangle. Stephanie is using a 5-meter ladder to reach the top of a wall. To be stable, the ladder must be placed 1 meter from the wall. The ladder reaches 4 meters up the wall. Does the wall form a right angle with the ground? If not, how high up the wall should the ladder be in order for the wall to be perpendicular with the ground? The length of the ladder is the hypotenuse, so substitute 5 in for c. The distance from the wall is one of the legs formed, so substitute 1 in for a or b and solve for the remaining variable, which represents the height along the wall needed to create the right triangle. Using the Pythagorean theorem, a squared plus b squared equals c squared, and substituting in the values that we know, we get 1 squared plus b squared equals 5 squared. Simplifying, we get 1 plus b squared equals 25. Subtract 1 from both sides of the equation. 25 minus 1 gives us 24. So b squared equals 24. Take the square root of both sides of the equation, and we get b equals the square root of 24, or approximately 4.9. The ladder has to reach about 4.9 meters up the wall to create a right triangle. Since it only reaches 4 meters, the wall is not perpendicular to the ground, so the answer to our question is no. It would have to reach up 4.9 meters. How to check if a triangle is a right triangle. Check if the sides satisfy the Pythagorean theorem by substituting the hypotenuse for C and the legs for A and B into the formula a squared plus b squared equals c squared. If the side lengths create a true statement in the formula, then the triangle is a right triangle. If the two sides of the equation are not equal, then it is not a right triangle. That is our lesson for today. Thank you for joining us, and I hope you enjoyed it.